the opportunity. Really exciting. Can people see my screen already? Or yeah, okay, right, because wasn't entirely sure to me. So let me just introduce myself and then go straight into the topic. So I'm Matthias Thierbach, also data platform MVP, also based in London, even though I'm not originally from Britain. You already mentioned Tyndall, which was very kind. So I had some involvement with that as a Power BI contributor. And well, generally, I invest a lot of my time and resources into tooling and DevOps tooling in particular around Fabric and Power BI. So, which is also why I'm really excited about today's topic, talking about branching and branching strategies. I don't think that is an area that is talked about too much in the Fabric and Power BI space, even though I'm extremely passionate about it. So hopefully I get to share some ideas and some insights. I'm very happy for this to be a rather interactive session. So if any questions come up, put them in the chat, and Halil, if you'd be so kind to just make me aware. It's I don't particularly just want this to be a lecture. So the more questions, the better. Also ensuring that whatever I talk about is relevant to the audience. So I want to start with a few fundamentals. Want to talk about the concept of environments, then introduce a few different workflows and talk about some practical advice. Before I get started, huge apologies to begin with. I was going to do quite a few demos. I'm not going to do them because I had a pretty pretty severe sort of breakdown of things earlier due to my Fabric trials expiring. Yeah, I had a fairly hectic afternoon leading up to this as I was frantically trying to prepare demos, but ultimately, sadly, did not succeed. Was trying very hard even some 5 minutes ago, so my apologies. But nonetheless, the topic is more about concepts in any case, so I don't think demos, whilst they would help, are crucial here. Okay, cool. So branching, which is obviously in the title here. Why do we talk about branching? What is it? What do we achieve with it? So I'm assuming some degree of Git and source control awareness and knowledge here. And I'm sort of thinking that once you've made it over the first barrier and embraced source control to some degree, branching is probably the next one you're interested in. So here is one example of, just to get us started, of what a branching workflow might look like in Fabric. And specifically, this is one which seems to be quite pushed by Microsoft, looking at the tooling Microsoft is providing. I've tried to make this a little interactive here. So the idea is that we have a main branch, which contains definition of our projects, and we use Git integration, Fabric Git integration, to do a two-way sync between a team workspace and that branch, That team workspace is generally used just for review. It's not meant to be used for development. For that one, the idea is to actually create feature branches of main, and where we basically have a safe, isolated space for experimentation and for changes. Those feature branches in Fabric Git integration specifically create private workspaces, which are linked to those branches specifically, and which are meant for all development work. In an ideal world, by one single developer. We then use a pull request, a PR workflow, to do a coordinated merge of those changes back into main. Ultimately, those changes yet again get synced to our shared workspace, where we basically integrate and combine changes from a number of developers on a team. That's just a really rough overview. I also showed that, one, because hopefully it's to some degree familiar, two, because we've come across a number of concepts here. But so why are we actually talking about branching? What are the benefits here? One is collaboration, right? I already mentioned that. For a sizable team to all work on the exact same version of items and workspaces is not a great idea, and definitely doesn't scale. So we've already seen having isolated individual feature workspaces is one solution for that. I mentioned experimentation. Sometimes you aren't quite sure whether the changes you're making will ultimately make it into production. Having a safe, isolated space where you can quite easily revert whatever you've done is the solution to that. And once again, having a branch is how Git enables that. Isolation I already mentioned for both of those, and also the ability to roll back worst case in production if necessary. So those are all the bits we can we get from using branches. What we saw in the chart earlier is that by convention, we generally use a branch called main to represent the most stable version of our system. Before I get into different branching strategies, in addition to the one I've just shown, I want to talk about the concept of environments, because I think the concept of environment is should be a lot more prominent when it comes to branching strategies. I sort of mentioned it in passing when I went through the example previously, where we saw where we had one shared team workspace, and we had other isolated workspaces, both of which can also be thought of as different environments. And I think it's quite important to consider that everything we do around branching ultimately is geared towards us having a well-defined flow of changes into different environments, production being the ultimate environment in that setup. However, environment is not what we're looking at here. Environment is more something like this. So basically, defined deployments, named and labeled deployments of our system. We can think of that as different workspaces, or we can think of that as collections of workspaces. A few ideas around environments, production and pre-production. So everyone obviously is familiar with what production is. So that's basically the version of our system that is shared with our stakeholders, with our end users. Any other environment, by definition, is pre-production. Those environments only have a purpose because they allow us a guided flow of changes into production. The second bullet here is quite important as well. And we saw that in the example earlier. It's quite important for us to distinguish between shared and isolated environments. Shared meaning multiple people, multiple teams, or entire teams have access to the environment, as opposed to isolated, where it's one single individual developer. As I mentioned before, in terms of actually making changes, it's not a good idea ever to do that in a shared environment. That's what isolated environments are for. However, shared environments are required when it comes to review, when it comes to bringing together changes from different developers and making sure they all actually work in conjunction. So in terms of testing and sign-off and review, having shared environments is really important. And then obviously production, by definition, very much is a shared environment because you generally have more than one user. And then the next distinction I wanted to make was between permanent and temporary environments. Permanent, again, production is the ultimate example here, but you may also have a shared development environment for your team that exists constantly and is always used in order to integrate changes before they go into development, which is different from temporary environments, which only live whilst one developer works on one particular feature. In DevOps language, the latter, the temporary environments are also called ephemeral. Sorry about this, but if you ever come across that term, you now know what it relates to. Let me skip that. So another thing I wanted to introduce is the concept of GitOps. And by the way, that's going to be the sort of final foundational thing I'm talking about. So I've mentioned the term DevOps a few times. I'm assuming that most of you are familiar with that. Basically, a concept from the software world, which was quite revolutionary when it was invented in terms of how developers actually think about the full life cycle of their code, and most importantly, developers taking responsibility for things like testing and deployment. GitOps is a evolution of that, which is much more recent, much more modern in a way, and it fully embraces Git as a source control system to be the single source of truth for everything that makes up your system. So much so that with a GitOps approach, any automation is basically triggered by activity in your repository. For instance, pushing to a branch might trigger some automation, opening a pull request, closing a pull request, deleting a branch, or creating a tag. So those are all activities that are very common and occur frequently in a Git environment. And with a GitOps approach, you basically control all automation, all deployments, etc., just by those kinds of activities, as opposed to having a separate deployment system where you have to click buttons and launch certain commands in addition to all the source control work you're already doing. So if you then link a GitOps approach where you basically tie branching and PRs, etc., to your environments, you have a very neat way of being able to automate jobs around environments, for instance, creating them, updating them, destroying them, or running particular jobs. What's also very important and very unique to a GitOps approach is that everything is held in source control, specifically your configuration as well. Oftentimes the term infrastructure as code is mentioned here. So that means you would be able to basically lift and shift an entire repository and recreate everything that makes up an environment just from what's in that repository with no further involvement necessary. Okay, so let's have a look at a few real-world branching models, because again, Git as a source control system is quite low level. It gives us a few sort of basic artifacts to play with: commits, branches, merges, tags. That's pretty much it. So actually using this in anger to collaborate within a team, particularly at scale, requires some conventions, some agreements, some rules of how we're actually working with all these artifacts. So a few things that come to mind here is, how do we name our branches? Who has ownership of particular branches? How do we merge features? Who is able to merge? Is it done manually? Is it done using an automated process? How are we reviewing and signing off features? Do we have a well-defined process for that? Do we know who is actually in charge, and how would they signal to us whether or not they give their sign-off or they don't? Deleting branches, that is very important. That's something which many systems sort of forget about in a way, and then you end up with many orphaned branches because they never got cleaned up. And ultimately, what is the path for changes to go into production? So how do I get to a release? So those 6 points, from my point of view, should be addressed by a branching model. And selecting one as a team is very crucial. So it's quite important, I would say, for you having thought about those kinds of questions and what your preferred answers are, because ultimately that determines what branching model works for you. And let me just mention a few more items I missed out earlier. Versioning, if that's something you care about, is quite important. Hot fixes and rollbacks, environments are already mentioned previously. So basically, this is just a slightly different perspective of what I mentioned on the previous slide. Okay, so I wanted to talk about a few example workflows that are out there and well defined and something to you can choose from. And I want to end up with a particular sixth option, which is something I've been working on lately over the past few months. Sort of taking the best of each of those and applying them specifically to what's needed in Fabric. All right. So if we want to do a little bit of history, Git flow arguably is one of the first defined and published Git workflows. In fact, I mentioned history here. This one does go back quite a while. It was initially talked about in 2010, 15 years ago, which, as you can appreciate in the world of tech, is like centuries. So this is definitely a bit dated. And what Git flow, what makes Git flow is what you can pretty much see just looking at this chart. It is not easy. That's the whole point of actually putting this chart here. So Git flow is quite, well, you may say over-engineered if you don't want to be very kind to the authors. Git flow basically has a number of permanent branches. We can see master, hotfixes, release, develop, and feature. It has various rules of how you actually interact by making changes on different branches and creating the pull requests and merging back and forth between them. So for instance, you can see the two branches in bold, master and develop. They are they're definitely permanent, whereas other branches are short-lived. So for instance, a hotfix branch would only be used if a specific hotfix is actually needed. Let me contrast that with this one, GitHub flow, which unfortunately is very, very similar in terms of name, but as you can see very visually, it is completely different and has a huge difference, massive simplicity. So GitHub flow, and that's really something I'd like you to take away, is not Git flow, not at all. And it pretty much has a single main branch. Nowadays we call what used to be called master, nowadays we call that main. And it has a number of very short-lived feature branches where the idea is that any work is normally broken down into small chunks. It's then conducted in a feature branch, and the goal is to merge those changes back into main as quickly as possible, thereby also removing or deleting the feature branch. So this seems to be what Microsoft has had in mind when they designed the Git integration branching model, which I started off with some 20 minutes ago. So if we contrast those two, I think we get a good idea of what the full scale is in terms of a very, very simple as opposed to a very complex branching strategy. So Git flow has many branches, quite complex, but also very structured. GitHub flow is a so-called trunk-based or mainline Git flow, and it's tailored around a single permanent main branch, which is always meant to be the stable version of the product, frequent releases coming from small, short-lived feature branches. which, if we stay on the right side of GitHub flow, very nicely allows for CI/CD. So CI/CD, continuous integration, continuous deployment, sort of being the full automation around how I integrate changes into my shared branches and how those changes are pushed into environments and ultimately into production. On the left-hand side, Git flow, this is more tailored towards having explicit releases. So as opposed to doing frequent releases, as soon as something's ready, we sort of wait and accrue changes on a dedicated branch and then release them at a certain point in time, usually sort of bundling up a large number of features. So testing, GitHub flow, the agile, simple model on the right, very much relies on automated testing. If you don't automate, you basically can't do the CD part in CI/CD, which particularly in the Fabric and Power BI world is very problematic nowadays because we have very few automated testing tools. So in a way, one could argue that proper CI/CD is actually not possible at all because of the lack of testing capabilities in Fabric and Power BI. You always have the choice of either not testing, which is obviously ludicrous, or relying on manual testing, which certainly requires an approach that is a lot less agile than GitHub flow. So with Git flow, where we have more structure, we can afford to have a lot more manual testing points in place. Main branches, we already seen those. So cons, I already mentioned that. GitHub flow only really works if you have as much automation in place as possible. Otherwise, you won't achieve the speed that's sort of required by the flow. The con on the Git flow side is that there are many branches to maintain. There's quite a bit of overhead. You definitely need someone who is really well on top of things to make sure that no one gets confused about where they're meant to merge something into and whether a certain branch needs updating or not. So there we go. Applying this to Power BI specifically in a very, very simplistic way, you could argue that something like a semantic model, something which is a very foundational part of your analytics system, something that requires a lot of rigor in terms of quality checks and reliability, is probably more tailored towards something like Git flow, where you have planned releases where you also don't rely on releasing very frequently. Whereas on the other hand, reports, for instance, you can very easily afford to publish small changes continuously into production, for instance. First of all, the impact of those is a lot less severe. Secondly, it is probably quite common, that sort of small cosmetic changes are done in reports quite frequently and in direct response to stakeholder feedbacks. Whereas, designing, developing, testing, and deploying entire new measures and tables and sort of analytical models that ultimately reside in a semantic model, that's probably not something you're generally going to push out every 5 minutes. Just to sort of show how it doesn't have to be an either or, right? You can easily pick different models for the type of product you're actually working with. Okay. So to provide a few more examples of what's available sort of in between those two extreme examples, right? I would definitely consider them quite extreme in the sense that GitHub Flow is extremely agile and again requires you to have a huge degree of automation, whereas Git Flow is quite extreme in the sense that it requires a lot of process steps and a lot of overhead. GitLab Flow is one example where we have a good mix between the two. And we can see, similar to GitHub Flow, we also have feature branches that can go straight into our main branch, but then we also have environment-specific branches, which are used to actually make releases. And I think that's quite a neat concept and definitely works quite well in my mind. Where we're basically saying, yes, what's on our main branch is considered to be stable, but it's only stable as far as the dev team is concerned. As far as my stakeholders are concerned and what's actually available in production, I want to have an additional step here by basically picking a point in time where what happens to be on my main branch should go into production. And then I do that by actually merging it into a dedicated production branch or also a pre-production branch, as we can see in the chart here. So that is a nice variation of GitHub Flow, I think, adding an additional process step for something to actually become a release. Okay, so this is a very nice side-by-side comparison of some of those flows. Definitely have a look at the link at the bottom. That's the source for that chart. I definitely do not claim ownership of it. Just grabbed it from this particular blog post, and it's a neat way showing 5 different models and basically which and what kind of branches they rely on and how they actually merge between branches. Just to mention, because we didn't explicitly have that before, on the left-hand side, trunk-based development basically says, I'm not using branches at all. Everything I do goes directly into main, which works for a single developer. It arguably does not work for a team. So there we go. All right. To add a few more flavors here. Microsoft have published on their Azure DevOps documentation how they actually use branches. And in fact, Halil mentioned my involvement in the Timnit development earlier. It's certainly something which I experienced firsthand when I contributed to the Power BI team. So we also, as you can see, as our center point, have a main branch, the one displayed in green here. We also have topic branches or feature branches or bug fix branches. which are short-lived and are owned by individual developers. And all of those ultimately commit back into main, as we can see. However, quite similar to what we saw with respect to GitLab flow on the previous slide, for things to go into production, Microsoft creates dedicated release branches. So the example here is they're called M129 and M130, obviously for subsequent releases. And those are created from one particular point in time on main, to allow us, or to allow Microsoft in this case, to sort of freeze development and then go through the various stages of pushing things, to their end customers. If you're not familiar, Microsoft tends to release features and updates through various rings. They start internally and then gradually go out to the wider public. So basically, there's a quite a duration of time that passes between, let's say, M129 being created and the M129 feature ultimately being accessible to everyone using Azure or Windows devices. So yeah, that's definitely has its advantages and its pros. We can also see over here that it is possible, if necessary, to push urgent hotfixes into a live release branch. So this topic branch shown in red here is meant to indicate that a particular fix was necessary whilst a feature was already being rolled out to the public, and the dotted line here indicates that this particular topic branch would have been merged into main, but it would also be merged into this particular release branch. I can see there may be a few questions on the chat. Do we want to take them now?
If you would like to answer two things in the chat window, but as it's totally up to you, you can answer them at the end of the session if you like.
Okay. Have you seen anything in particular which would make sense for me to pick up now? I can't really afford to sort of read the whole chat history now.
Maybe at the end of the session, Henrik and Jake can unmute themselves and
we
can have a chat.
Means, even better. Can they unmute themselves, or do you have to do it?
Henrik, Jake, if you would like to unmute yourself, our guest.
Obviously, no.
Yeah, I can. Hi.
Hi.
Can you hear me? Yeah.
Yes.
My name is Henrik. I would just. I'm kind of going into this. I don't know if I'm the expected audience, but I saw the headline. How to use these systems as a Power BI user. And maybe the angle is more kind of if you're coming from a more technical background, because I have worked with Power BI in 8 years, and I have also spent a lot of time with the work from Matthias and who we followed this and trying to get into this and using it myself. Deploying to committing to Azure DevOps and pushing to workspaces. And with the intention to kind of implement it in the future with a lot of report builders that we have. The report builders are not building the semantic models. We are building that in the BI team. And then we have a lot of these Power BI. And I think there would be a lot of value to get them started. But it's kind of a far away from these concepts that you're showing here, because it would be much too. So my question was, I have another question later if you have some thoughts about that. But my concrete concrete question was that you're starting using deployment pipelines as a way to go from dev to test to prod. And my concrete question here was that using the various branching techniques, that's kind of an alternative method to get to deploy the things to these 3 workspaces compared to the deployment pipelines. Is that correct?
Okay, so I'm assuming when you say deployment pipeline, you're talking about Fabric deployment pipelines.
Yeah, you showed it in the beginning. Yeah.
Yes. So, I mean, the deployment pipelines obviously circle around workspaces, right? And they basically sync item definitions from one workspace to another, right? That's what they do, and that's how they work. So, which means, let's say hypothetically, you have a setup with 3 different environments, which is quite common, obviously. The question then is, how do you get all those changes into the first of those environments, so that the deployment pipeline can then pick up
Sure.
and move them into UAT and production, for instance, right? And
Sure.
so that question is sort of what we're talking about here, because the assumption, my assumption is, and let's be more explicit about it, if you want to think at scale, you probably wouldn't have a large number of people contribute to that very first workspace, right? And so if you agree that that's not a good idea, you then need to figure out, well, how can you have a better process for parallel work that goes on within your team to all end up in this initial deployment pipeline environment, right? And so that then leads to branching, right?
So when you show the pre-production branches, then it's not. Do I misunderstand if I think that the pre-production branches are connected? For instance, a test branch is connected to a test workspace instead of using the first, as you say, the developer workspace, and then using deployment pipelines. I'm a bit confused about that.
Right. So from my point of view, the crucial point is branch ownership, and well, actually, environment ownership. That's really what I'm talking about, right? If you're happy to have your initial environment in your deployment pipeline jointly owned by the whole team, in the sense that anyone has edit and contribute access to it, and anyone can make changes on that environment, then deployment pipelines work very well, right? Because then everyone contributes to the first environment in your deployment pipeline, and you go through the deployment pipeline process to propagate to higher environments. But from my point of view, that's a big if, because you invite lots of potential problems with people undoing each other's work, or with someone making a change, but then being blocked by someone else having some work underway that isn't ready yet, for instance, right? So the whole point I'm trying to make is, if you're really thinking about working at scale in a team, you have no alternative but to think about individual feature workspaces where every developer can basically work on their own, and then use some process to bring their changes back into a shared environment, right? And when it comes to reports, one easy way to think about that is actually people's local machines, people's desktops or laptops, because for reports, we happen to have Power BI desktop, right? So we can actually have a fully valid environment on our own machine. We don't necessarily have to have individual workspaces in a capacity as we do for pretty much all other Fabric items. So so that works, but you ultimately have to solve the problem. How specifically does everyone contribute to that shared environment that starts your deployment pipeline? If you use Git, would you allow everyone to just commit into a joint branch? I would say no, because the big problem again is there's no process here, how you actually coordinate potential conflicts, how you review whether what developer A is contributing is good enough to go into the shared environment. So just a few thoughts to think about here. Ultimately, moving over to source control and using branches is absolutely necessary when it comes to coordinating parallel work in a team, right? If you only have one single developer responsible for every one of your crucial items, then you're fine, you have no problem, and this topic is irrelevant for you. But if you want to be able to scale at an organizational level, you have no choice but to think about branching. So that's the point I'm trying to make here.
Thanks.
Okay. Okay, let me move on at this point. There is another model I wanted to mention. It's sort of a variation of what we've seen before, something I personally blogged about because it's a model I developed for my own teamwork a while ago. And again, we've got a main branch here, which is protected. Individuals cannot simply commit and push into main. They have to do so via a workflow, specifically one that requires using feature branches. Feature branches get merged into release branches. Release branches are basically used to combine all changes that ultimately go into a new production release. Once we're happy with what's in the release branch, that goes into main, gets tagged, and gets deployed. So here we go. That's yet another variation of sort of common pattern that's coming up here, I would say. Okay. In the interest of time, I'm gonna be very, very quick here. So look at the pyramid on the left.
We can extend the session if you like.
Sure. Thanks. So if you want to think of your hierarchy of environments as a pyramid, then your highest environments are the most protected ones. That's basically production and anything that's close to production. And the lowest environments are the ones where you get your hands dirty, right? Where actual development happens. So you can see that looking at the downward arrow, in terms of dev activity, there's a lot more happening at the bottom. Looking at the upward arrow, when it comes to quality and control, there's a lot more happen as you go up. So yeah, hopefully that's a picture that's useful for you. And what I wanted to show here is how this pyramid on the left maps to a branching model on the right, where we're basically saying main represents production, pre-production, or what's called the UAT environment here, user acceptance testing, that sits in a temporary release branch. The dev team works on integrating their various features on a shared develop branch, and actual development happens on short-lived feature branches, which are owned by individual developers. So here we go. Okay. Those are all items I've mentioned before. So I wanted to finish with a particular model that applies all of this to Fabric. And again, just coming back to my intro, this is someone, there we go, thanks. This is what I was going to demo, but unfortunately, due to my Fabric trial capacity running out, found myself in a bit of a pickle. So my apologies. I'll definitely, I'm very keen for this demo to become public. So watch out. I'll definitely share this on social media one way or another over the next week or so. But the idea here is, let me see if my yeah, here we go. So that works. So the idea here is that, again, as we've seen many times before, we've got a main branch that sits on the right in terms of our pipeline. Main is considered pre-production. So basically, this model will automatically deploy into our test environment, the one where we interact with our stakeholders and ultimately get sign off. And once stakeholders are happy and we have sign off, we actually use explicit tagging on our main branch in order to trigger a production deployment, which means in addition to having a branching model, we have the added benefit of actually having explicit version numbers in our system, and particularly held in our Git source control system, that where those version numbers represent everything that was that went into a particular release. Which ultimately also allows us easy rollback, right? So let's say we published 2.1 and we found some bugs only in production. Because we've got those tags in place, we can then very easily roll back to 2.0. So going to the left, we've got a shared development environment, which is basically for integration purposes. And that one is linked to a dev or develop branch. Here we go. However, it is read-only. So no one will ever explicitly contribute to dev. This is something which actually only happens through a dedicated PR process. So any features developers want to contribute to future releases need to be merged into our development environment using a dedicated PR. Developers work on feature branches, again, a concept we've seen a few times now. And what this model does specifically is to account for what's very unique for Fabric, namely the fact that, unlike with Power BI, where you can pretty much replicate, an entire report or entire semantic model on your local machine, what you need in Fabric is actually an environment a workspace or a number of workspaces to run your stuff in, right? Fabric does not run on your laptop. So the idea is to use automation, which is why I was talking about GitOps earlier, to say whenever a new feature branch is created, it will automatically trigger the creation of a corresponding feature environment. That's an environment which is ephemeral, i.e., it will only exist for as long as that feature branch is live. The developer then actually uses this particular environment, think of it as a workspace, for all their development. And ultimately, obviously, they need to get those changes back into Git. So they basically use tooling to sync those changes into Git so that it ends up in the feature branch. When they're happy and they think they've completed their job, they create a PR. The PR then, again, using GitOps automation, fires up an ephemeral PR environment, which allows the development manager or whoever else is sort of in charge of signing off that individual's work to review everything in a dedicated, isolated environment. So once the PR is merged and goes into dev, let me do it this way. The PR environment is automatically destroyed. It will then also delete the feature branch, which will lead to the feature environment being destroyed, which means, again, you do not end up with the very common problem of accruing old orphan branches, and you certainly do not end up with a problem of accruing lots of one-off development workspaces, because automation basically takes care of cleaning up after you. So in terms of environments, there are only 1, 2, 3 permanent environments. We only have 1, 2 permanent branches, and everything else is ephemeral. Everything else is temporary and only exists for as long as necessary. But without the team, without the individual developer having to do additional steps to clean up or to even propagate an environment, et cetera, et cetera. So again, this is a model which are fully automated. In fact, if you went to FabConf in Vegas earlier this year, Mike and I showed an end-to-end demo of that. I would have loved to show another one today, but please bear with me whilst I sort out my capacity access. All right, cool. So that's something I wanted to share. So to summarize, the model I'm trying to promote here is to say that in a Git-based system, you should ideally have environments which do not require any manual intervention or interference. Everything that goes in and makes up an environment should come from your CI system only. That obviously requires a degree of parameterization, which I would have covered in the demo. This is, again, something which your CI system would cover. Development only happens in isolated environments. So that's really, really key. Anything that's considered a shared environment is read-only. Ideally, no one other than your deployment principals will have contribute access to those. Pretty much PR and merge processes are used in order to promote changes to higher environments, which can also be combined with approval processes, depending on who your approver is. Most CI systems have very neat ways to automatically assign approvers to your PRs. Okay, right. Just looking at time, I don't want to overrun too much. Let me just have a look whether there are any more pending questions here.
We can extend the session for any time you would like. It totally depends on you, Matthias. But
Right.
when do you think this demo is going to be ready? Maybe we can schedule another full session that covers everything in demo.
Right. I mean,
So
I'll definitely
I'm leaving that totally up to
I'll
you.
definitely
Be my
prepare it
guest.
by tomorrow. So anytime from early next week, I'm ready.
Okay.
It was just really unfortunate. Sorry. Okay, cool. So Jake's asking repos per tenant, per workspace, or per related items. Well, I mean, that's almost a religious question, right? Which is probably why you put it here. There's no right answer here. Lots is possible, you know. If you haven't heard this, there's a concept of monorepo, which exists in various contexts where you basically have one huge gigantic repo that contains a whole number of projects, and then everyone contributes to that same repo. Famously, I heard recently that apparently Google uses a single monorepo for all their code. And apparently, because that's so big, they had to create their own Git tooling to actually handle that. So that's one extreme. Probably not the first option you would choose. Monorepos, you know, require a lot of automation, a lot of coordination. If anything, a monorepo has the very obvious drawback that cloning it would take a long time, certainly longer than just having a small, more confined repo. So my answer to this question is, again, the question was, should we have a repo per tenant, per workspace, or per related item? My answer would be, it should be per team. A repository, as I've tried to make the case over the last hour, is all about collaboration. It's all about sharing and jointly contributing to a shared system. And so it makes a lot of sense in my view that teams, you know, groups of people who work together, work on the same repo, and that other teams who work on their own systems, you know, have their own repositories. But yeah, this could be a whole talk actually. So there we go. Yes, so I'm just gonna run through a few more slides here. If lets me. So just a few practical tips I wanted to share. If you're not familiar with that, Git branches actually allow hierarchical names, which is a very, very neat feature. If you're not familiar with it, check it out. It can, you know, change things massively. Obviously, we've seen main as a very common branch, so that's not hierarchical and has a good reason. But basically, whenever you create a Git branch and you put a forward slash in there, you automatically create a folder structure. And I personally use that heavily for things like feature branches, release branches, or even in a team collaboration context to indicate that a particular group of branches is owned by one individual. You know, you just take your initials and put them in the folder structure. Already talked about shared and private branches. Absolutely recommend to use branch policies to protect shared branches, to make sure that people cannot, not intentionally and not accidentally, merge into branches that should require a PR, very important. And then also really important, having a good cleanup in place so you don't accrue old, obsolete branches and environments. And again, the demo I'm going to show will have that fully automated so it doesn't become a burden on you and doesn't become an extra to-do. You definitely need to decide on a branching strategy. It can be as simple as GitHub flow. It can be as complex as Git flow or anything in between. Environment parameterization, that's probably a different talk. Coordination of concurrent work, we haven't really talked about that, but people oftentimes ask about merge conflicts and how to avoid them. And what to do if they occur. The best way is to coordinate that any parallel work within a team never happens on the same item. We mentioned Tyndall earlier. Tyndall splits semantic models into multiple files, which would allow you to basically do parallel work on the same semantic model, but for instance, on different tables or so without any risk of a merge conflict. So there we go. That's really important. Tags for versioning I've already shown as an example. I'm going to skip that one. That's a different topic. Going to skip this one as well. Here we go. Cool. So yeah, I've got a few resources to share in terms of, first of all, Fabric branching and Fabric CI/CD. Those are all Microsoft resources. Those links are related to Git basics and Git tutorials. Those links are related to the various Git branching strategies I've introduced. So you can read about those 5 on those links. Questions, we already handled a few, but if there are any now, then by all means, fire away.
I have one.
Yes, please.
So it's related to if you are not, say you have a Power BI report. And you just want to do a quick change. So you don't want to go into Power BI, you decide to do that just within the files itself. Or even if you're handling a Git merge. So you're manually editing the files. There's no good tooling right now for just schema validation of Fabric items, right? So in effect, it turns a CI process into a CD process because the only way you can really test is by deploying. So I don't know if there's any good tools that are out there that exist.
Well, I mean, I'm assuming you're talking about PPIR here, where you've got the report broken down into a hierarchical structure of JSON files, where each JSON file is schema-based. Is that what you're talking about?
I mean, it could be either, right?
Yeah. So if that's what you're working with, then yes, you actually do have tooling, because by convention, each of those PPIR report files has a schema reference. So if you open them,
well, yeah, on the
in
report
VS
side,
Code, you will see
model.
that there's a schema violation there, right? In terms of automating that, I happened a couple of months ago, I actually published an open source library for PPIR specifically, which happens to contain schema-based validation for PPIR files. So I haven't really blogged about it very much, but it's available on GitHub and on NuGet, and it actually happens to contain a validator. So good idea. I can see how you would how you could use that for CI purposes, and making sure that you don't even get to the deployment stage. So yeah, that's a great question. But yeah, so I've worked on something that can fulfill that need, but haven't really spoken much about it.
Okay, so I'll do
Great.
reports, but I guess there's still a bit of a gap for semantic models then, unless there's an equal schema for Tyndall.
Yes. So the the tabular object model libraries, they perform schema validation. So basically, if you try to read a Tyndall project using Tom, it will fail immediately if there are any syntax problems there. And again, this is something which happens client side. You don't need to deploy in order to find out the problem. The only caveat is that where you've got embedded expressions from using other languages like DAX or M, those will only be covered at deployment time, right? So the Tom libraries for Tyndall only look at the sort of Tyndall document structure and validate that. They will not validate DAX expressions or M queries, but at least it would give you quick feedback, right? I guess the reason why you're asking the question, also for everyone else's benefit, as a developer, you want really quick feedback whether or not some change you've made is good or not, right? So you don't necessarily want to have to wait till something gets deployed or wait and see whether or not it fails to deploy. In an ideal world, you would want to know much sooner than that. So I think both for Tyndall as well as for PPR, we're in a good position now. We have those tools. Okay, thanks for the question. Cool. So yeah, let me just move to the final slide. More than happy to share the demo using some other channel. My apologies. Again, very sorry. But nonetheless, I tried to focus on some concepts and some sort of key ideas you should consider and think about when it comes to using Git at scale and Git in a team, and hopefully people found that useful.
Thanks a lot, Matthias. Is it possible to share your slide deck into chat window?
Of course.
Currently, just not to make people wait for that links. That's great. I think Fernando asked for this.
Yeah, sure. I'll PDF
it
it right after the session and put it into the chat.
That would be great. I totally agree with the idea coming from Henrik. Even if you are a single developer, you should learn how to use that GitHub stuff, Tyndall, CI/CD. Because before that, let me give you my own example. I was starting a basic model, version 1, then version 2, then version 3. Then I have started using SharePoint, which is not very helpful at all. We have to use these integration tools. And I agree with another comment. There is no single tool that covers everything. It's not available even on Fabric. There are several tools like PBI tools, which Matthias created. We have to follow up this issue. This is very technical and confusing subject for many of us, including me. When we say developer, are we talking about data model developers or report developers? I've started seeing people that who knows very little about data modeling, but great at creating visualization. Interesting days, definitely. instead of writing something, Henrik, you can unmute yourself if you're writing your question.
It's not really related to Matthias' great session here, but so it could be nice maybe with a session, you know, focusing on how these Power BI developers get started with version control. You know, when you're a single developer and you actually could have crazy benefits of these version control and template automation, and how do we get them started best possibly, so they maybe in some years also we can scale them and start using more advanced branching techniques, but we have to get them started. That could be interesting with
Well, I have shared 2 different links from our previous recordings with Matthias and Stevie, who is another data platform MVP from the UK. I would strongly suggest watching that GitHub integration. Let me find the link again. Introduction to version control. It's in the chat window. Introduction to version control, Git and Power BI. This is must-watch video for everyone if you are starting. If you are starting those things from the beginning.
Sure.
And
but maybe not maybe also not only an intro, but someone who has really experience with this for the last year and say what is working, what is not working. So not just an intro. There are some intros around, but maybe a follow-up on these intros.
Let's watch the intro videos first. It's not basic intros. It's quite detailed one.
Okay.
I pasted link to another one, which we organized with Matthias 2 years ago regarding Tyndall. Tyndall is one of the core technologies under the hood. And then after that meetup, maybe we can schedule another session with you, Matthias, showing everything in a real demo.
I'll definitely take the request on board in terms of having stuff that's more low level. Well, no, not more low level, sorry, more introductory. That wasn't the intention for today's session, but I hear you. And arguably, there's probably a huge volume of people out there who would benefit from stuff that is a lot more basic and hands-on. So arguably, that's also much harder to achieve. So I'll have a think about it.
Okay, thanks a lot, Matthias.
Cool. Okay, I just PDF'd the slides so I can actually add them already, so I don't forget. If I can find it, and here we go. There we go.
Yeah, Visual Studio Code is another way. I agree with that.
Cool.
Sometimes there are multiple ways to do the same thing. Okay, everyone should be able to download a slide deck. Okay, thanks a lot for joining me, Matthias. It was very heavy, technical, but excellent presentation. Thanks a lot for your time, for your effort. I agree with that. VS Code is another tool that we can use for that kind of stuff. And it also has lots of things with the AI as well. Amazing days, definitely.
Okay, very good. Thank you. Appreciate you hosting me.
It's my pleasure, definitely, Matthias. Okay, when we get this demo ready, we can schedule another session with you.
Mhm.
I'll be more than happy to reschedule it again. Schedule it
Sounds
again.
great. Fantastic. Awesome. Thanks.
Okay, thanks a lot. Thanks a lot for everyone joining us. See you at the
Thanks.
next meetup.
Good night.
Okay. Bye.